Okay. Can everyone hear me with the mic? Yep. Okay, excellent. So, I'm Chris Alba Hamilton. I work for Nexmo. Today, I'm going to talk about our experiences in applying platform as a service APIs for machine learning. Both the talks today are about fighting fraud. And so, without further ado, today I'll be exploring these three myths. It's a myth that you need some data science, statistics, PhD to be hired so that you can be productive in building a machine learning system. Secondly, it's a myth that it takes a long time to get something valuable to your business or to your startup with this machine learning. And finally, it's a myth that only Python can be used for machine learning, or even a language like R. R, more like arse. So I'll be mentioning our favorite language, Java. Now, first of all, a bit of background about who we are at Nexmo. Nexmo is a leading cloud communications platform. We offer APIs for B2B usage, for SMS, programmable voice, two-factor authentication, and chat. So the background of this is we offer a cloud platform as a service. So we have the analogy, we are a vendor that takes care of all the complexities. We don't expect our clients that are using our most popular API of SMS to be worrying about low-level details of gateways, telecoms, contracts with wholesale text message buying, adaptive routing, high quality deliverability. All that's abstracted away from the benefit of using Nexmo. And there's an analogy here in this talk that as Nexmo, we leveraged platform as a service APIs for machine learning, and we're very productive with that. So let's move on. Back in 2016, I was very concerned with the issue of SMS fraud. And I wanted to find a self-learning automated solution to tackle it. So first of all, in the audience, has anyone ever received a text message that is totally unsolicited? It's from a company that you've never done business with, and it's most likely, you know, annoying. It's trying to sell you something, trying to, you know, effectively it's spam, okay? So hands up, who's ever received such a message? Okay, yeah. So the next one, which is a subset of that, is if anyone's ever received a message that purports to be from a bank, it's pretending to be from your bank, and it's saying, hey, you know, there's an issue with your banking, you need to log in ASAP and re-verify your details. And the text message would have a hyperlink to a bank, and the page is designed to look like the bank's page. You know, it's got their logo, it's got all the details, it looks like that. The URL is like some variant of the bank's real URL. And it's asking you for all sorts of details like your credit card number, your credit card PIN number, your CVV. So, you know, as soon as you disclose that, a fraudster can go off and use your credit card, or go off and they've got your internet banking details that you've detailed everything on this page. So this type of text message, or a variant, which is trying to steal the login of your cloud system. So we all know celebrities who've had their cloud storage hacked. There's multiple ways of doing that, including keylogger, but one is certainly through this type, which is phishing. So hands up if anyone has received such a phishing text message. Okay, yeah. So this is totally unethical, okay? And Nexmo goes to great lengths to crack down on this. The vast majority of our usage is totally legitimate B2B usage. But like any business, we have to fight fraud. So here we have a full-time team of talented fraud analyst staff who fight fraud, as well as systems to tackle fraud, one of which is what we did with machine learning. So in 2016, we already had existing technology of a manually configurable spam filter which scanned the SMS body before the SMS is sent. And if the SMS body matches a pattern in the spam filter, then the SMS is not sent, it's rejected. But can anyone think of a problem with this design? Just shout out. Okay, anything else? Shout out.
It's manual.
Exactly, that's it. The hint's in the title. So we're not leveraging scale economies because you can't have humans constantly updating this thing. Fraudsters are always changing. They're always changing their language in their text message, okay? So I wanted to leverage scale economies. So, we have our team of full-time fraud analysts, but we should be able to scan hundreds of thousands of text messages very, very regularly to check for fraud without having to hire more fraud analyst staff. So the SMS spam filter is not self-learning, it's manually configured. My hypothesis is I could reduce SMS fraud by additionally introducing machine learning solution. And I say that that's after, because sometimes machine learning has false positives. So therefore, you're not saying, oh, we think this could be dodgy, so we're not going to send the SMS at all. The SMS would get sent, but it's actually very soon after reviewed by staff because it's flagged up to them in a system that they use, which I'll go on to later. So in 2016, we looked at what was available in the market for platform as a service, APIs, and machine learning. We looked at Amazon, Google, Microsoft. The architecture was defined for a Java-based microservice leveraging Spring Boot, reading data from our databases related to Nexmo SMS API, and it was utilizing vendor-provided machine learning. So in late 2016, the result of this work, Fraud Detection Service, FDS, went live. And in the event it finds suspected fraud, it's highlighted on an internal web application of which the Nexmo staff have access to. This particular feature is authorized only for the fraud analysts. They can then see that this fraud, suspected fraud, has been flagged up, and very quickly they can suspend the API account, or they can report back to the system that it's a false positive, so the model can be retrained, okay? So the result of this was FDS was a big success throughout 2017, and it further helped Nexmo fight fraud. So I'm going to now talk about our process with vendors. Now, we discounted Microsoft Azure because at the time, Microsoft didn't actually include a Java API. We also felt the documentation wasn't so great. Amazon Machine Learning was chosen during a kind of rapid prototyping phase. So that's us using command lines, scripts, SQL to load data from our databases, and CSV file manual uploads, so we can get a feel for the vendor's API. We haven't yet committed to building a Spring Boot solution or using Apache Quartz with scheduling, right? You're quickly iterating an R&D manual to understand the API. But during that phase, we became concerned about the lack of incremental updates API feature. So that's kind of like, imagine you had a training data set with, let's say our initial training data set during that phase was 10,000 text messages. And that's something that you're telling the system, here's all the messages that I know are fraud, and here's the messages that I know are not fraud, to give you the initial sample. So you load them up into the system. From that point onwards, you have a scheduled task where you provide your latest text message bodies to the system, and then you ask the system to predict, is this fraud, yes or no? Now, we did a simple model, only yes or no. We didn't have a maybe in between, just yes or no, and we have a threshold. If it's above the threshold probability, we think it's fraud. If it's below the threshold, we say it's not. So our concern here is we were looking to have a scheduled task that very regularly uploaded the latest SMS bodies. So let's say we had, and this is running at a high frequency. So let's say we have 1,000 new SMS bodies to be scanned. But let's say in our existing model, including the training model and including all the messages we've already uploaded, we have, at this point, let's say 100,000 messages. Now, the lack of incremental updates means that rather than uploading 1,000 records, you're uploading 101,000 records. You're effectively reinserting your entire database all over again. You're not just, doing the insert of the delta, okay? So we were concerned, would this really scale when we get to millions of text messages? Is this not a bit crazy doing this re-upload of your entire model all over again? So we took a gut reaction and we thought, we really want incremental updates. You only upload the delta, the 1,000 rows, not the 101,000 rows in this example. So next, we look at Google Prediction API, and this featured the incremental update. And in the end, this is actually what we used, Google Prediction API, which I'll go into more in a moment. So we launched production. Our system was immediately delivering business value, fighting fraud, and it had positive feedback from stakeholders, the Nexmo staff, the fraud analysts. So everything was great, right? Well, as you can predict, a few months later, Google dropped a bomb. I love it the way that Google cheerfully say, note, minor point, FYI, the whole thing that you're depending on is going to be deleted. So with the end of life, unfortunately they gave us a year's notice of this. We had to look for alternatives. And if I highlight the offering we were using under labeled old here is Platform as a Service, Google Cloud Prediction API. And the new is they have two things. They have the replacement offering is Platform as a Service, Cloud AutoML, but it's now domain specific. And by that I mean, at the moment you can only and exclusively use it for machine vision, image processing, photo processing, and so on. Google's aim is they'll gradually release more domain-specific versions of it over time, but their only version is vision processing, which, as you guess, we're not doing, okay? Secondly, their other new offering is infrastructure as a service, so slightly, it's lower level than platform as a service. Infrastructure as a service is Google Machine Learning Engine, which I'll call MLE. But MLE is not a fit, because before, we were quite happy that there was no exposure to TensorFlow. TensorFlow is the underlying machine learning technology, open source framework built with C++ and Python. We were never having to run TensorFlow, to host it, to do anything with it. But now it's completely the opposite. You actually have to run TensorFlow themselves, create a TensorFlow model, tweak it, play with it, and then upload the model to Google MLE, and it's used then as a kind of cloud execution platform of your pre-created model. So, therefore, we replaced all usage of Google Prediction API with Amazon ML. Back to where we started, déjà vu. Now, I'm going to talk about some of the tech we use to make our fraud detection more accurate of the SMS fraud. So we used orthogonal sparse bigram, OSB, a bit more catchy, transformations. Now, this processes the text message body into what you see on the right here before it's submitted to our machine learning vendor. Because what you're doing is really trying to catch a fraudster, phishing or SMS spam, who might change their language in a particular way. So you imagine if this wording was someone pretending to be a bank or pretending that you had some amazing tax return, and if only you log into this fake site and provide all your bank details and bank password, they could switch words around. They could change the language structure somewhat, but the semantic meaning would still be the same. So what's neat about this is it increases the chance by turning it into lowercase and also chunking it with OSB, it increases the probability of getting a match. So prior SMS fraud, the fraudster then changes his language pattern, but but it's still the underlying same sort of message, we're still more likely to find it this way, okay? So here's another example. One idea is to use 1 underscore added per skip. So you see jumps over the lazy becomes jump underscore over, jumps double underscore the, jumps triple underscore, right? However, we ignored that typical approach because we found from trying it out, looking at the numbers, that we got better fraud detection results by consistently using only 1 underscore. Okay, so we weren't wanting to bisect our data model as much as the example at the top. We were quite happy with the one below, and trying that out showed we were getting good results. So challenges, I'll briefly mention QA environment. I think if machine learning is at the heart of your business, then naturally you'll want a QA environment, regression tests, all the rest of it. However, in this use case, machine learning was only tertiary to what we do. And this is not a business critical application. So we, almost for everything that Nexmo does, we have very thorough QA, we have expert QA engineers, we have a huge suite of unit tests and acceptance tests. However, this project, which was a relatively small project, we effectively saw that the effort to set up a proper QA environment, have regression tests, look, we've made a change to the model, you know, how has it changed? Would that really give the value in slowing down a project delivery that we wanted? So in short, we used a spreadsheet to show statistical effects of retraining as a result of before and after model changes, and that shows how each time did we gain or lose accuracy. So the data set wasn't changing. Instead, what was changing is the way that you saw previously we changed whether we're doing double underscore or single underscore in that, you know, when you've got. So when you try out different things, you can see the effect, okay? And we did that manually. We didn't have like regression tests and QA engineers. So that's extremely unusual for Nexmo. For everything else, we do have QA. So what sort of use cases are applicable for machine learning? Now, at a very high level, like kind of abstract, you could say, what's a fit? And I think it's repetitive, repeatable. If you gave the same problem to 5 expert members of staff, domain-specific experts, the same problem and the same data set, are the 5 people going to consistently reach the same conclusion? Okay? So I think that's a good fit, because then that's something you can turn into potentially machine learning and your layer of logic on top. So machine learning is a great opportunity to innovate for your companies, for your startups. You can think leveraging machine learning platform as a service, get quicker time to market. You can think, you know, what problems can I solve in my company? What problems can I solve as a startup idea? So really think about that. Here's the APIs. Amazon ML is on version 2, platform as a service, Java API. Google Cloud Machine Learning Engine is infrastructure as a service. It's just version 1. Microsoft Azure Machine Learning, the Java API was only announced in October 2017, and they've helpfully pointed out this Java client is not production ready. I also point out that we didn't really look so much at machine learning vendors who only offer a constrained application-specific offering. So for example, some only do machine vision, or some only do language translation. This didn't fit the use case we needed, okay? But your use case, perhaps they could be a fit. So there's plenty others that are not on this slide. So if we look at the Java APIs, there's no point showing you Google Prediction API, because that's about to die. In terms of Google Cloud Machine Learning Engine, there's no code sample on GitHub for this, and instead there's samples of Google API client library for Java, but it's not the same thing. So we feel that there could be some work done on the kind of developer support of this. In terms of Amazon ML and how we use it, the next 2 slides just go over that super quick. The first phase is create a data source where you upload files to S3 or Redshift or RDS, and that's for your model. The second step is creating a model within that data source, okay? And again, I highlight these APIs are asynchronous calls, so you can, not show in the slide, you can then use the Java API to find the creation status. For example, there's Java futures, things like that available. So on to the next slide. You create a data source for the evaluation. Again, you know, we mentioned it's S3 or Redshift or RDS. You then create an evaluation on that data source, and there's some code sample for that. And then you create a data source for the prediction, and again, create a prediction in that data source. So this is the thing, you've got your training data set in your platform as a service machine learning solution, and then you're putting in some text messages that you want evaluated, and then you're going to get the result back from the system. Does it think it's fraud? And if it thinks it's fraud, it's telling you the probability, you know, the probability at which it has the confidence that it may or may not be fraud, okay? And we have a probability threshold that we cut off, okay, of whether we think it's fraud or not. Again, that's configurable. Oops. So finally, to recap, we mentioned at the start, do you need to hire someone who's got a PhD in statistics? And I would say, thanks to machine learning platform as a service, for the standard use cases, absolutely not. You don't need that. And our developer did a wonderful job without that background. He got up to speed quickly, was highly productive, and we've delivered a lot of business value for us by leveraging a vendor's platform as a service. And I would just highlight, though, that beware that machine learning platform as a service can be like a black box, right? So the very benefit of simplifying it somewhat can also be a problem, because then you think, how did it come to this particular conclusion? You know, what's the steps that were run here? What part of the particularly influenced it? And it's limited disclosure. So if you log into like Google's dashboard for this, there's limited information on what was done to get there. So that's the weakness of it. So if you do a TensorFlow model yourself, you have a lot more control over it, okay? So this is the tension between ceding control of your machine learning to a vendor, the simplicity, quicker time to market versus reduced insight control of the algorithm, okay? So, in short, that's everything. We delivered great business value with that, and yeah, any questions?
Do you have anything about synonyms and different spellings of segments, American versus British spelling?
That's a good point. Yes, we don't have that at the moment. So effectively, if we had, like, for example, organization with a Z, an organization with an S, we don't have a feature built in to detect that at the moment. But clearly, if someone was to use that in a subsequent message, that would go back into our model. Also, our model covers all languages, because effectively our model doesn't understand English, it doesn't understand Chinese, it doesn't understand Italian. These are just tokens, abstract tokens in a sequence. So we actively fight SMS fraud in China, and you know, it works all over. But yeah, it's a good point about language.
How do you know what messages are fraudulent? Do you get reports from your client?
Okay. So before the solution existed, we had built up a database of, you know, here's the people that we've suspended due to product abuse, and specifically SMS fraud. We have like a checkbox. You can label it as specifically SMS fraud, as opposed to, say, voice fraud or, you know, credit card fraud. So that then allows us to query our database and find the history of these messages. Then we can filter for unique, right? Because obviously fraudsters keep sending the same one again and again. And then we can put that into the cloud for the initial training data set. And we're telling the cloud, this is fraud. We know this is fraud. We're telling you this is fraud. Then we provide some messages that we know are not fraud, and that's the initial training. From that point onwards, we're providing it with the data, and it processes it and does a prediction. Now, as I highlighted, false positives are possible, right? So staff can click a link to say, this is not fraud, false positive. That then feeds back into the model in the next time in the scheduled task, Apache Quartz. There's yet another angle, which is proactively report fraud. It's like, hey, the system never knew about this category of fraud. It's some, amazing new thing, I don't know, fraudulently promoting Justin Bieber CDs, I don't know. So therefore, staff can track down this text message and click report fraud to SMS. Sorry, report fraud to FDS. And all that's through our existing bespoke staff business application. Okay? Yeah?
Does the Amazon ML offering now also offer incremental updates then?
No, we just said, So in the end, we find that the time to upload these files is not actually killing us, So yeah, you have to upload everything again, but c'est la vie.
You mentioned the diagrams. Did you do any other features as part of your inputs, or is it just that? And the other question was you say you have limited access to the APIs to control how it's learned. So could you train the hyperparameters? Could you tune them at all, or are you just using essentially the defaults that they're providing?
We're essentially using the defaults, and there's limited control, as you say, on the parameters. We tried out a range of other things, like we didn't go straight to the OSB, but this was the best result. We have a few other things, like secret sauce that I'm not supposed to disclose, because if this got out in the wild with SMS fraud, the fraudsters would love to know. But yeah, it's a good point. And in short, if you move to a lower level model, like infrastructure as a service, you have full control, right? But when you go higher level, you have to cede a little bit of the control. So it's really the balance. Is your business, is the heart of your business machine learning, or is it just tertiary, like it is in the case of Nexmo's usage? Anything else? No? Okay, so yeah, finally, at Nexmo Engineering, we're hiring, so we're always on the lookout for talented software developers. Predominantly we use Java. And if you're up for the challenge of reinventing communication, join Nexmo. And finally, I'll say, tonight is actually Burns night. So here I'm at with my Hamilton scarf. And we celebrate one of the world's greatest poets. So anyway, thanks for listening to me. I'm off to have another coffee to survive from my coming back this morning from a flight to the States. So feeling pretty tired, but thanks for listening.